This device here is something that we call a demonstrator, and the demonstrator for us is a way of showing people how we can practically utilize research results. Research activities and results that we have developed in the project of MiLo, the environment in the control loop. And the idea behind this environment in the control loop is that you are measuring a lot of parameters that is related to the environment that can also affect the way that we are living, the way we are performing activities in our industries, in our society. In the same way as the environment are affecting us, we are also at the same time affecting the environment. And we need to have control of this, and we need to measure it, and we need to make intelligent decisions based on fact that we are collecting from sensors and developing information from. This is a cool stuff. These are some experimental equipment that we have create a device that can move automatically on the surface, like on asphalt, and scan the surface for example, different friction coefficients, and detect if there are like ice or snow or if the asphalt is wet. And another very interesting feature we have here, this is a LiDAR sensor, a light radar, that can view the surrounding asphalt area and detect if there are any kind of items lying on the asphalt. And every airport in the world has a very large or severe security thinking around these issues about foreign object debris, FOD is called. And they are continuously scanning the asphalt and the runway for finding any kind of items, and we need to remove them. So this device here can do this automatically. It can find it and it can report the GPS position, so someone can go out there on the runway to remove this stuff. Equally, we can drive this four-wheel electrical motorcycle in the ski slope to measure different quality of snow in order to report this and get some idea how the condition of the ski slope actually is.
In this project we have investigated remote operation, particularly for controlling the air traffic at a remote airport. In this context, there is a live video stream that is transferred from the remote airport to an operator sitting somewhere in Sweden. The importance here is that this is happening now. It's happening in real time, and therefore you have to do this very, very quickly. All the processing, from the capture, the processing, compression, and recreating the images and present it to the operator. The most important results of this project has been that we have understood what kind of information is required, how shall we present it, and in what form shall it be. That means you can have different graphical representations of the same information, and then you need to place it somewhere in the video stream so that it's useful for the operator. So it's not hindering the task it should do, or it is placed somewhere that is not visible. We have also investigated latest AI algorithms that are used for detecting events. We have also looked into neural networks that have a representation that enables training with much less data. We have looked into how feedback within such networks will enable a better representation and therefore hopefully will give a better result in the end. Mid-Sweden University is situated in a region with long distances, so this kind of technology is very useful for a lot of different companies. So we have the forestry, where they want to remotely control different parts of the processing chain. We also have a mining industry nearby that wants to take away the dangerous parts of the mining, and by doing so they use this kind of remote technology.
Remote Tower Center do perform air traffic services from a digitalized center in which we use cameras and screens to have a visual overview of the runway, apron and taxiways. In the conventional tower, the actual air traffic controller sits on the airport. This is a centralized air traffic service that we perform. So in this center we have 4 airports presented in 4 remote tower modules, and we have 15 air traffic controllers giving the service to the airports. Together with Mid-Sweden University, we have made it possible to demonstrate how we can actually detect, target and identify moving objects on an airport and around an airport. It had taken some time, but I think now it's mature to have it in operation for our purposes, to have direct visual tracking of moving objects on an airport. To work with Mid-Sweden University has been most crucial and have a lot of impact on our product. For me, working for Saab Digital Air Traffic Solutions, I don't know if we have seen all these new fancy features, have seen the possibilities and seen possibilities outside performing air traffic service without Mid-Sweden University. They are more creative in their mind. We're a little bit digital in our thinking, just following a rule book and do what says in the rule book. But to get help in our thinking has supported us a lot.